and today's topic is carrying capacity. Are there limits on populations? The world's population of people right now is pretty close to about 8 billion. Do you think the world could support our population if it grew to 14 billion or 50 billion? Can it go on forever? What happens if we exceed that limit? For the most part, I think we know that there is a maximum. We can only support so many people on the planet. Why do you think that is? Well, it has to do with something called carrying capacity. Carrying capacity is the largest population of a species an environment can support for any long period of time. It's the maximum that we can support. And it's unique to every species in the environment they live in. Now, there's four main factors that's going to determine how many individuals there are, what the carrying capacity is for that ecosystem. Materials and energy, food chain, competition, and density. We're going to look at each of these separately. First off, materials and energy. Now, this basically refers to the bottom of our food pyramid. Anything at the bottom of our food pyramid, our producers, our plants, they need energy from the sun, they need an adequate amount of water, and they need carbon and other essential nutrients in order to grow. The more available these important resources are, the more plants can grow in an area and the bigger an ecosystem that can be supported. Above the level of the plant, we get into other resources like food supply. Animals that eat plants and other animals that eat other animals beneath them in the food pyramid need an adequate supply of food in order to be able to reproduce and survive. So the population sizes at any trophic level, any feeding level, then will be limited by the population size or the biomass of the level below it. Number 3 is competition. As the population gets bigger and bigger, there tends to be more competition in between the members of that population. Some of that population is intraspecific. We talked about this in our last lesson. That's when we have two members of the same species competing. For example, two wolves are competing for a deer to eat. There could also be interspecific competition if it's between two different species. In this picture, we have two white foxes, both wanting to eat the same rabbit because both of these are the same species. This is intraspecific. Notice the spelling. Interspecific, we have a fox and a wolf both competing for the same rabbit. Competition increases where resources are scarce or where population sizes start to grow. Now, the population size itself eventually brings in our fourth factor, and that's density. How many animals are in a given area, or plants or species of any nature that we're talking about? Population density refers to how many organisms can live in that area at any one time. If we get too many organisms in an area, we get overcrowding. That increases things like stress, it increases things like the spread of disease, and possibly even parasites. Even now with our current COVID-19 situation, the spread of the disease is faster in areas where there is high population densities. This is why we try to do social distancing to spread the density apart, to get people further away from each other. Now, any factor that affects animals, of anything that we've talked about that relates directly to the density, is called a density dependent factor. It depends on density. For example, if there was lots of bears like we have in this picture in an area, the aggression between the males fighting over mates and fighting over food resources would be more so than in areas where they don't see each other as much. That's a density dependent factor. Quite often the spread of disease is a density dependent factor. The more animals or species in an area, the easier it is for the disease to spread. That's a density dependent factor. There's also density independent factors. These are things that can affect how many animals live in an area regardless of whether there was lots of them there to begin with or not. A forest fire is a great example. It completely wipes out the producer level of a food chain. And obviously, at that point, whether there was just a few animals or many, the amount of individuals that can now be supported is much less. Another major density independent factor is construction. In construction that humans do, building roads or building new communities, we destroy the natural ecosystems, and the amount of individuals that could have been supported is now significantly less. The carrying capacity, that maximum amount, can be graphed over time. In this graph, if you look at the purple line, you can see that the population has grown steadily since about the year 1800, and around the year 1850, we noticed that it overshot the carrying capacity. We hit this point where all of a sudden there was a massive die-off in terms of the number of individuals. At some point around 1860, the numbers had gone below the carrying capacity, and reproduction increased, and the ability for lifespan increased, and the number of individuals increased. This up and down pattern is very common in all populations as we hit the carrying capacity. We'll have overshoots in the number of individuals that are living in an area, followed by massive die-offs, followed by resurgences, followed by massive die-offs. If we draw a horizontal line that roughly splits this down the middle, these overshoots and die-offs, we can estimate the carrying capacity for that species. In this graph, we notice that the horizontal line that would roughly split apart the up and down segment would be around 1.5, 1.6 million individuals. Under ideal conditions, a population will naturally increase until it will overshoot the carrying capacity. And at this point, the environment can no longer provide that species because there won't be enough environmental resistances, there won't be enough food, there'll be too much crowding, there'll be too much competition. The population's going to start to die off. There won't be enough resources for them. There'll probably be more disease. Once the population has gone down below the carrying capacity, population recovers, and the numbers go up once more. So think about it. What kind of things do you think could increase the carrying capacity in a community? What kind of things could decrease the carrying capacity in a community? For lack of being able to have a classroom discussion about this, I'd love to see you guys make posts under the Posts tab in Teams about things that you believe could increase or decrease carrying capacity. And we will have a forum discussion in that manner. I would also like you guys for today to complete task number 10 in your workbooks. We're almost done with the ecology unit. That's all for today.